Hey everybody, and welcome to the Lesson 8 activity, Bouncy Ball. This is one of my favorite activities of the semester. I feel like I say that every other activity. But this one really is fun because you get to create an animation that I think is pretty interesting. Literally a ball bouncing around in your window. If you want to see what the finished product looks like, definitely watch this YouTube video. I think you should watch it and maybe even try to do these steps on your own without following along with this video first. Use this video if you get stuck. And really, going off the to-do comments in bouncyball.java and watching this video pretty much gets you to the starting point. And you'll notice the specifications are only, or literally only 2 steps long. When the ball reaches an edge, reverse the corresponding delta direction, and then make sure your solution works when you resize the window. Your bounce checking shouldn't involve a specific window size at all. Also, this little last sentence here, it's kind of weirdly placed, but it is a good hint, and we'll talk about it later. But first, let's get started with the activity. I've already created my Activity 8 project in Eclipse, so I am going to go ahead and download this guy, save the page as a Java file. My little save window will pop up for me. Looks like Chrome appends.txt at the end. Let's just get rid of that. We'll save it in our downloads folder. And we'll save it there. Go over to Activity 8, right click it, import the file. Select the directory we're going to import from, which is downloads. We're already there. Hit open. We'll select bouncyball.java. There it is. Excuse me. Go ahead, hit finish. Open that bad boy up. Awesome. Let's go to the steps for the specifications and see if it gives us a good starting point. Keep the ball in bounds, following the to-do comments in the paint component method. So awesome. Let's go ahead to Eclipse. Look for that paint component method right here. And we've got some getting the width and height like we do in all of our graphics projects. We set the color, fill in the background, add on to that X delta. That should look familiar from your P0. However, there's also a Y delta, and you've got a to do here to keep the ball in the bounds in the x-axis, and one to do here, ball and bounds in the y-axis. So there's only kind of 2 steps to this activity. However, those steps are more challenging than to make up for it. So let's go ahead and hit start and see what we get right off the bat, because it does work. So you see the ball going there. However, it goes off the end of the screen in the y-axis and doesn't come back. Let's start that again. And you can see there it goes again. And so if you start it again, you'll see the kind of starting direction is kind of random. It looks like it's going in different directions down there. And so we got to add some conditionals to check our changing x and y values and make sure that our ball stays in bounds, because what we want is for the ball to be bouncing off the walls of our little window, like it's kind of like throwing a racquetball against a wall, right? Just bouncing around inside of there. And if you haven't watched that sample video at this point, I think it'd be helpful for you to pause this one and go watch the one that's linked in the activity, just so you know what the finished product looks like. So it seems to kind of keep going off at the bottom in the y direction. And so let's try to make the y value bounce back off the wall first. So when the ball's traveling down the screen and hits that bottom edge, what's going to cause the ball to bounce back up instead of just keep going down? Well, as you can see, what's causing the ball to move is we're adding to its x and y value, and we're adding on x delta and y delta every time paint component gets called. And just like all of our other animated animations, we are calling paint component a couple times every second to create that animation effect by adding on that little bit to the x and y coordinate every time. And so instead of causing the ball to move down the screen, which again is in the positive y direction, as you can see in the illustration here, traveling down the screen is the positive y direction. Traveling back up the screen, bouncing off the wall, would be in the negative y direction. Well, when it hits that wall, the direction needs to change. Now, how can we change that direction? Well, think about it. What's causing it to move is that y delta value. So when we detect a collision with the wall, we need to reverse the y delta. So the first question is, how do we detect a collision with the wall? Well, that should give you a hint that we are going over if statements in this lesson. And so we already know what the height of the screen is. So when that ball reaches that height of the screen, we need to reverse the y delta value. So let's start where we know we need to. We at least know we need an if statement to check if the ball has reached the height of the screen. And then we need to figure out what that expression is going to be. So let's see. If we have if y equals height, right, then we can reverse y delta. So let's see. What is, how do we reverse y delta? Well, if you remember, we actually do have that unary operator. The minus sign is overloaded. You can use it as subtraction or to negate something. So you could actually just say y delta equals negative y delta. So that's valid Java code. Let's run that and see what happens. See if our ball bounces back. And it kind of bounces back, but did you notice that the ball kind of sinks into the wall a little bit before it bounces back? Yep, well, keep in mind that the ball is being drawn from the center. So y actually represents the y value of the center of the ball. So how can we correct for that being in the center? Well, to move that drawing point down from the upper left-hand corner of the ball to the center, we subtracted radius from it. And we know that as we go down the screen, that the y value of the bottom of the ball down here is going to be more than the y value of the center of the ball right there. And so we actually have to add on the radius of the ball to the y value in our if statement to get it accurate. So if y plus radius equals height, then y delta equals negative y delta. Let's try that out and see if it looks good. Awesome. Now that is a beautiful bounce. Now what happens if we move the screen and kind of resize it? Like it said, this should be resizable and the ball should always stay within bounds. Let's try to figure that out. See if it adapts to that. So I'm going to resize this, drag it, and that worked. Let's try it again. Uh-oh. Where'd my ball go? It's gone. So when we're resizing it, it didn't exactly work well. Well, first of all, let's think about this. If y plus radius is equal to height, what happens if we resize it and the ball goes past the edge of the screen? Well, I don't think that's going to work. Now, what if the user resizes it in between calculations and the ball isn't exactly at height when this if statement gets called? Well, we're going to completely miss it and we're never going to reverse the y delta. So instead of doing equals equals, let's do greater than or equal to and see if that helps. So it still doesn't seem to help. Now, it at least works pretty good still when we're not resizing it, but it's still not quite working. It worked that time. Now, this is when that picking up the ball and moving it back to the edge of the screen becomes important. Because check this out. If we move it up and then move it back down, you saw the ball just kind of got stuck on the edge of the screen there. You can see that the ball kind of comes back. Well, let's figure out the X position. You can see the ball just got stuck on the bottom of the screen there. Let's figure out the X and get it kind of bouncing back, and then try to figure out the rest of this. So for the X delta, we can do the same thing. And let's figure out that left edge. So, oops. So this side of the screen. Let's figure out that edge. And then we'll figure out all the other ones. And then maybe we can talk and try to debug a little bit. But let's get our ball bouncing when we don't have it resized at all first, before we do any more thinking. So to get the ball to bounce back on the X edge, we basically have to do the same thing, but with the X value. So again, if our ball is over here, and we're bouncing off of this edge, this is the positive X direction, and then this would be the negative X. And so our center point is right here. So again, positive X goes in this direction. That's the positive X direction. Uh-oh. And then positive Y, of course, is down the screen, as we're used to. Still getting used to this drawing pad, everybody. Sorry. So X plus radius, again, is going to be the side of the screen on the right. So if X plus radius, this time it's going to be greater than or equal to width, X delta equals negative X delta. Let's try that out. Boom and boom, our ball is bouncing back. So while we're at it, let's figure out those other edges. So for the Y, now is this going to be an if or an else if? I think we can do an else if. Now, we're just reversing the sign, right? So couldn't we combine this into one if statement? I think we can. And this would be an or, because it's either going to be at the bottom edge or the top edge. There's no way the ball can be in two places at once. So, and let's go back to our drawing. Let's mock that up again. I think this is working really nice. So if we're at this edge, again, this is now positive Y, this is negative Y. If you recall, remembering the way our axis is different on this end. So to check if it's at the top edge of the screen, we're actually going to have to do X minus radius, not X plus radius. And I apologize, Y plus radius. Y minus radius is less than or equal to, right? Because we're going in the negative direction, and that would be 0, just like height is the bottom, so the height of the screen, top of the screen, Y position is going to be 0. We reverse the Y. Same thing with the X. Again, an or, because it's either going to be at one side of the screen or the other, or the middle, and if it's not, we don't need to reverse X delta, we just need to keep adding to it. again less than or equal to 0. And let's try that out. So this works awesome when we don't resize the screen. Our ball is bouncing, it's staying in the window, we just bounced off all the edges and it's working. But again, it needs to be able to resize. And it works pretty well when we do it slowly, but as soon as we resize quickly, it doesn't work. Although we can kind of bring it back. It's like the ball gets stuck off screen, and no matter how long we wait, we can bring it back in. And this is where that whole putting the ball back in bounds is important. Because what's happening when we resize it so quickly is that the ball is actually getting stuck off screen. Because think about it, and we'll let the program run while we talk about this. Like, what's happening? Oh, I just didn't mean to undo that. There we go. So we got to think about what's happening when the ball gets off the screen. So if it's greater than or equal to height, let's say it goes off the screen in the y direction. I'm actually going to go ahead and delete this whole thing. So this is the bottom of our screen. If I could draw a straight line. And not mess up our paper. There we go. So this is the bottom of our screen. This is height. And our ball is off screen. There's the center of the ball. If we're in this position and we're here, well, y plus the radius is way greater than height. And so we just reverse the delta. Come up here, add on to y delta, and then we reverse the delta again because we're still off the screen. Because our y delta is pretty small. That's what causes the animation to look so smooth. And so the ball's perpetually just stuck off screen, bouncing back and forth, which is why even after running for a couple minutes, I can go like that, and the ball comes back in bounds. But here's the cool thing, is you are in complete control of this ball. I mean, you wrote the program. So you're in control of where the ball is at all times. And so we can say, if we're at the edge of the screen, like if our user resizes it fast enough that our ball gets stuck off screen here, and there's that corner just to make it look a little more realistic for you, well, let's just put the ball exactly back on the edge of the screen and reverse the delta, so it's going to keep bouncing that way. So now our ball appears to just stay in bounds at all times because the program's running so fast, and this repositioning happens in between calls to paint component. Anyways, it's not like you're going to see the ball jump off screen and jump back. It's just going to appear as though it stays in bounds at all times. So that's what we mean by picking up and putting it back, is that if we're at y plus radius is greater than or equal to height, well, let's reverse y delta and set y equal to height minus radius. Now, what about when we're at the bottom edge? Or the top edge, depending on your perspective with that Java axis. When we're at the bottom edge, we're not going to be putting it at height minus radius. We're going to be putting it bottom plus radius to get the ball back on this edge. Where if the ball were positioned at that top of the screen edge, if we were like this, our ball's x-axis would have to be 0 plus the radius of the ball. And so we're actually not going to be able to do this in one if statement. We're actually going to need to be in an else if statement. So let's cut this guy out. We're not going to need that or, we can take that out. And again, reverse y delta, because we still need to flip it. And then we'll set y equal to just radius, right? Because 0 plus radius is still radius. And now we can do the same thing for the x as well. Let's cut this guy out. Put that in an else if. Again, we'll have to reverse x delta. And then, oh, we got an extra parenthesis up there. And again, if let's say, keep on accidentally shifting that paper. If we're on this edge of the screen, our wall is way out here, we need to move it to, in the x position, 0 plus radius. If I could draw radius better, that was really bad. Because right there, from 0 in the x position to the center of the ball, that's radius. That is the radius of the ball. So x is going to be equal to 0 plus radius. And this is our left side of the screen. So we'll say x equals radius. Again, just like the y, 0 plus radius is just radius. And then this would be, of course, width. X equals width minus radius. Now let's try that out. And now you can see no matter how you resize it, no matter how crazy or fast you get, your ball's always staying in screen. This is what I think is really fun about this activity. It's like playing racquetball. If you've ever played it at the Boise State Rec Center, you just go crazy and that ball's bouncing off the walls all over the place. So let's try out this extra credit, see if we can get that working. So if I want to randomly determine the starting color of the ball, I need to go to the Bouncy Ball constructor. And this is the class up here. Usually constructor's up at the top. It doesn't have to be. They put pink component up at the top, I think, so that y'all could easily find it. Down here is the constructor. It's only called once when the program first begins. It's also what sets up the timer that calls pink component. This is also where we initialize the ball color and initialize the ball anchor point. And you'll be able to, in the extra credit, because it is optional, randomly determine the starting coordinate. So I'm just going to randomly determine the starting color. So we've got our random object, and like we've done before, replace the random starting color. So it's just going to be a new color. And again, we'll do random.nextInt. Just like when we did our random color with a minifig activity. And we just have to call random.nextInt from 0 to 255. And actually, 255 is a valid value, so we're going to put 256 in there. And one more, RGB. So let's try it out. Is it red? The kind of brownish color. Let's run it again. Ooh, really exciting, bright, what would you say that, like cerulean? I don't know what color that is. And let's actually try to randomly determine the starting coordinates. So initialize a ball anchor point within panel bounds. So the valid points are going to be from 0 to x, from 0 to width. However, we also have to take into account the radius of the ball. So valid coordinates are going to be from 0 to width minus radius, and actually from 0 plus radius to width minus radius. So what we can do is we can do init widths minus radius and then plus radius. Well, let me explain that, because this way, if we get 0 from this, which is a possible value, we'll add radius on. So we'll always be drawing in the proper position on the left-hand side of the screen. And then we'll get up to init width minus radius. So if we add on radius to it, actually, you know what? That's not going to work, because if we get init width minus radius and we add radius onto it, we're going to get init width as a possible value. And as you know, the ball would be off screen. So we actually have to subtract 2 times radius. And this also has to be random. We're going to do the same thing with the y value with initial height. It's going to be init height minus 2 times radius, so minus the diameter, and then plus radius. That way, if we get 0, we actually get it drawn at radius, which is valid. And if we get init width minus 2 times radius and we add radius on, we'll still be radius amount away from the side of the screen. So we're always drawing our ball exactly on the edge, even if we get those maximum and minimum possible values. So now, as you can see, our ball's got a totally random starting point. There we go. Well, everybody, I hope that was fun for you, especially the end. We get to change the color of the ball. I love how you can kind of play ping pong with it when you have a finished product, and I hope it was fun for you too. So with that, I'll catch you all later. Congrats on finishing lesson 8. We're halfway there. Happy coding.